All right, guys, how are you doing? This is going to be the second video for Math 8, and who would have thought that I would be the one saying it? Please pray that school opens up quickly, because this is a lot of work, and yeah, I did not know what I was getting myself into. But hopefully, as I start learning more and more, and as I do more videos, I get more comfortable with it, and it becomes easier to do. But right now, it does take a while. Yeah, my first 3 videos took me about 6 hours to do. So hopefully that changes from now on. But hopefully I also try to work on the glare, because I saw a little bit of the glare, and so let's hope that this doesn't happen today in the video. But today we're going to see recursive rule for sequences, and this should be pretty easy if you remember the things I taught you about in sequences, about A being the value of the term and N being the number of the term. And that's really important because a sequence obviously always has a number of terms, and the first term isn't always 0 or 1. It's something different for each one of the sequences. So let's actually see what this lesson is about. All right, getting to the first example. Well, the first thing I'm going to do is, again, remind you, A equals the value of the term and N equals the number of term. So how do you write a recursive formula for sequence? So the recursive formula, it's really easy. It's something that we'll see here. And so the first thing is that we have to acknowledge the first term. That's literally what you have to do when you're doing recursive formula. First thing is look at the first term. The first term is a 2. So I'm going to put A of 1 equals 2. Wow. That was super hard. No, it wasn't super hard. It was difficult. So what then we see here is that we have done the first part. Now we have to recognize what is going on afterwards, okay? So in the first term, okay, we have A of 1, but then how do we actually find A of N? A of N means just any term in here. So what happens is that now we're going to say, we're going to use a notation that is going to be A of N minus 1. A of N minus 1 is going to be meaning the value of the previous term. What do I mean by that? So I mean this, the formula itself is going to be 2 times A of N minus 1. I'm going to put a little parenthesis here. That is going to be the recursive formula for this particular sequence. So what do I mean by that? Well, let's take 8, for example. What term is that? That's the third term, because we have the first, the second, and then we have the third, and then we have the fourth, and then we have the fifth, and so forth. So let's do it for the third term. All right, let's try to get 8. Not let's look at the 8, but let's try to get the 8. So I'm going to put A of 3. The value of the third term is going to be the same as 2 times the value of my third terms minus 1. 3 minus 1 is going to be 2. So hopefully everybody knows that. So 2 is going to be, the value of the third term is going to be the same as 2 times A of 2. A of 2 means the value of my second term. My second term is a 4. So instead of putting A2, I'm going to put 4. So my value of the third term is going to be 2 times 4, which is 8. Look at that. We got the first example. For the second example, what we have is A of N equals 1 plus 2N. But they didn't give us a sequence. They just told us, okay, this is the formula for a sequence. Find the first 4 terms, then you have to write the recursive formula. Well, this is not as hard. Again, if we understand that A is the value of N is the number of the term, we're going to put the value the first term is going to be 1 plus 2 times 1. So the first value is going to be 2 times 1 is 2 plus 1 is 3. So my first number of this new sequence is going to be 3. Then I have to do the same thing, but A of 2. So a of 2 is going to be 1 plus 2 times 2. And a of 2 then ends up being 5. My second number is 5. I think I already have a guess of what my third term is going to be, but I can't assume, so I'm just going to do it again. A of 3 is going to be 1 plus 2 times 3. So a of 3 equals 7. Hopefully you have caught on by now, but let's do it again anyway. A of 4 is 1 plus 2 times 4. So a of 4 is going to be 1 plus 8, which is going to be 9. Wow, crazy, right? So each time we're adding 2, but we're not asking you what's happening in the sequence. What we're asking you is, what is the recursive formula for this? So remember, recursive formula always starts with the first term. So we're going to say a of 1 equals 3, my first part, and then a of n, meaning to find any term. What I have to do, and always try to use the a of n minus 1 notation, is going to be the value of the previous term plus 2. That's what it would be. Why? Because if we pick the value of, let's say, 5 to find 7, right? So my third term. Let's do the fourth term. Last time we did the third. Let's do the fourth term this time. So a of 4. The value of my fourth term is going to be a of 4 minus 1 plus 2. Well, 4 minus 1 is 3. Hopefully that's not a big surprise for anybody. I mean, I know you guys are not really in the physical school, but hopefully you guys haven't forgotten that yet. So a of 3 is going to be 7. So a of 4 is 7 plus 2, which is 9. Wow, look at that. We finished another example. All right, and then for the final example, they give us a recursive formula and they tell us to find the sequence. I did not look how long do we have to keep going for, so let me check real quick. Find the second and third term. So why don't we find the first term? Because it's already here, right? So the sequence starts with a 5. Wow. So we already have the first term. So now we have to find the third and fourth term. Is it what it was? Second and third. My bad. Second and third. So now we have to find the value of the second term equals 3 times a of 2 minus 1. A of 2 equals 3 times a of 1. Value of 1. The value of the first term. The value of the second term then would be the same thing as 3 times 5, because that's a of 1 right here, it tells us. So a of 2, or the value of the second term, is going to be 15. And then the value of the third term, right? And then we're done with this example and the lesson. I'm excited. So a of 3 equals 3 times a of n minus 1. So a of 3 equals 3 times 3 minus 1. I should have written here. So I'm going to erase it real quick and then write it again. And so a of 3 is going to be 3 times 3 minus 1 is going to be a of 2. And a of 3, the value of the third term, is going to be 3 times the second term is 15. 3 times 15, a of 3 then is going to be 45. And then we got 45. And that would conclude the third example. And that is lesson 97. So hopefully you guys understood. If you have any questions, please either comment down below or comment in the Google Classroom page. I'm going to try my best to try to answer the questions if you have any. And if you like this video, make sure you like and subscribe. And you can obviously go and watch the other videos, although I do not recommend you watch the Algebra 1. It's probably a little bit too advanced. And so there's not a lot that you could watch. But, stay tuned for the next ones. So I want to thank all my likers, commenters, and subscribers. And I will see you in the next one.